So chances are you've built a retrieval augmented generation system that's pretty amazing with text. But let's be real, the world isn't just plain text, right? It's full of complex documents, reports, manuals, scientific papers, you name it. So today, we're going to level up and tackle how we can make our RAG systems understand everything else. Okay, so your RAG is a total genius with markdown files and simple text. But what really happens when you feed it a PDF that has a critical architecture diagram on page 15 or a table comparing financial results? The truth is, most standard RAG systems, they just see a blank space, or even worse, they just ignore it completely. That's the exact problem we're going to tackle. And that's where multimodal RAG comes in. To put it simply, it's a system that doesn't just read the words, it sees the whole document. It can process, understand, and pull information from images, from tables, from charts, and blend it all seamlessly with the text. And look, this isn't just a tiny upgrade. We're talking about giving our AI the full picture. Okay, so where do we even begin with this? Well, the most direct path is usually the simplest one, right? Let's dive into the first approach, using optical character recognition, or what we all know as OCR. The idea here is super straightforward. If your system only speaks text, hey, why not just make everything text? OCR tools can scan an image, like a diagram or a chart, and just yank out any words they can find. You then take that extracted text and treat it like any other chunk of information in your database. Simple enough. But, as you can probably guess, there's a pretty clear trade-off here. On the one hand, yeah, it's incredibly easy to just bolt an OCR tool onto your existing RAG pipeline. But on the other hand, it's brittle. OCR can make mistakes, for sure, but the bigger problem is that it completely obliterates the visual context. Think about it. A flowchart isn't just a bunch of words. The whole point is the arrows, the layout, and OCR just throws all of that away. So, that whole problem of losing context, it demands a much, much smarter solution. And that brings us to our second approach, which is using vision language models. All right, this is where the big idea really clicks. Instead of forcing images to become text, these models actually learn to understand both of them, in the same language, so to speak. They create this shared mathematical space, an embedding space, where the concept of a dog is represented in a very similar way, whether the model is looking at a photo of a dog or just reading the word dog. The absolute game changer here is a technology called CLIP, which came out of that awesome research from Rodford and his team back in 2021. By training on literally hundreds of millions of image and text pairs from across the internet, CLIP learned to connect visual concepts with how we describe them in language. This means you can now search for something like a diagram of an authentication flow, and boom, it pulls up the actual image of the diagram, not just text that mentions it. So the huge win here is that we get true multimodal retrieval. We're not just playing keyword bingo anymore, we're matching actual meaning across different kinds of content. Now, the downside? It's definitely more complex. You need a specialized vision language model, and putting it all together is a pretty big step up from just running a simple OCR script. All right, so we've got images and diagrams covered. But what about one of the trickiest, most structured things we deal with? Let's talk about tables. And oh man, this slide just says it all. You run a simple OCR over a table, and what do you get? A total mess, a jumbled up stream of text. The rows, the columns, the headers, all that logical structure that gives the data its meaning is gone. It's literally word salad. Model A, 7B, 2023. Model B, 13B, 2024. It's just meaningless. But when we do it the right way, we keep all that beautiful structure. We understand that parameters is a header, and 7B is the value that goes with Model A in that column. This means you can finally ask a question like, which model has the most parameters? And the system actually knows what you're talking about because it gets the relationships inside the table. So how do we actually pull this off? It's basically a three-step recipe. Step 1, you parse the table into a structured format, something like HTML or JSON. Step 2, you create a text description of that table that summarizes what's in it. And finally, step 3, you embed that descriptive text. That makes the table's content searchable, while letting you keep the original structure for later. So we've talked about handling images, we've talked about handling tables, kind of in their own little silos. But what if we could bring it all together? This leads us right to the cutting edge, the unified model. And this is where things get really exciting. The most advanced models today, they don't need separate pipelines for everything. They can take in an entire page of a PDF with all its text, its images, its layout, and understand the whole thing at once, holistically. It's like they're finally seeing the page the same way a person does. You know, one of the secret weapons that makes these advanced systems work so well is metadata, rich metadata. For every single piece of information, whether it's a paragraph, an image, or a table, we attach labels. We tag its type, the source document, the page number, maybe even a caption. Think of this metadata like super-powered labels or tags. They act as incredible filters, making our retrievals so much more precise. Okay, that was a whole lot of theory, I know. So how do you actually, build this thing? Let's switch gears and walk through a practical playbook for building your very own multimodal system. All right, here's your playbook, your step-by-step guide. First up, you've got to know your data, what's actually in your documents. Based on that, you choose the right tools for the job. Maybe OCR is fine for simple stuff, but you'll need Clip for diagrams and a table parser for spreadsheets. Then you run your extraction and processing for each type. And please remember to add that rich metadata to every single piece. Finally, you build your retrieval system to use all that great metadata, and then you test with queries that hit all the different types of content. And that really brings us to the big question I want to leave you with. There is no single best solution here. It all comes down to your documents and what your users actually need to find. Do you have simple scanned reports, or are you dealing with super complex technical papers? Answering that one question is what will set you on the path to building a RAG system that's not just smart, but truly intelligent.